Think for a second about how much your prompts actually repeat. The same long system prompt writing along on every single call, the same few-shot examples pasted in again and again, sibling branches of a reasoning tree that all start out identically. A normal serving stack quietly recomputes all of that shared work from scratch every single time, which is a staggering amount of wasted effort. RadixAttention, introduced by the SGLang team in 2024, flatly refuses to do that. It automatically reuses the model's cached memory across different requests whenever their prompts overlap. Let's break down exactly how it pulls that off. Start with the problem, framed as a simple before and after. The naive way treats every request as brand new. Even if 1,000 calls all begin with the exact same system prompt, the server rereads that prefix and rebuilds its key value cache from 0 every time. That's an enormous amount of duplicated work. Reusing shared prefixes completely flips that. When a new request opens with tokens the system has already processed, RadixAttention simply grabs the cache it built earlier and only computes the genuinely new part that follows. Overlapping prompts stop paying for the exact same work over and over again. Here's the machinery, followed step by step. A request comes in as a plain sequence of tokens. Maybe it shares a long common opening with something served just moments ago, or maybe it's almost entirely fresh. The system genuinely doesn't know yet, so the first thing it has to do is look. Cache memory lives inside a Radix tree keyed on token prefixes. Picture a branching structure where every path from the root spells out a sequence the model has already seen before, with its own slice of the key value cache hanging neatly off each node along the way. Matching walks that tree to find the longest cache prefix this request shares. Everything up to the split point gets reused instantly, so the model only has to compute attention over the brand new suffix that follows. Finally, the tree grows. The new suffix becomes a fresh branch, its cache attached for the next caller. A least recently used policy quietly evicts cold branches so hot, popular prefixes stay resident in memory. So what makes RadixAttention click? It really comes down to 3 ideas. Everything hinges on that Radix tree keyed on prefixes. It turns cache reuse into a fast prefix matching lookup instead of a guessing game. And it happens automatically without you tagging anything by hand. Reuse crosses right over request boundaries. A shared system prompt, a block of few-shot examples, or sibling branches of a reasoning tree all hit the same cache prefix in the tree, so the model ends up computing each shared span exactly once and never again. Eviction is what keeps the whole thing practical. A least recently used policy quietly drops branches nobody has touched lately, freeing memory for the ones that matter. That's what makes this such a huge win for agentic and multi-call workloads, where the same prompts overlap over and over, request after request. All right, let's lock in the 4 takeaways that matter here. RadixAttention, from the SGLang team, automatically reuses the key value cache across requests instead of recomputing shared prompts. Cache memory sits in a Radix tree keyed on token prefixes, so matching finds the longest shared opening fast. Only the new suffix gets computed, and a least recently used policy evicts cold branches to keep hot prefixes resident. That makes it a major speed up for structured, agentic, and multi-call workloads where prompts overlap. Want more of these AI internals in plain English? Standarity.com is where they live.